My name is Srilakshmi. My topic is theory of vector through degrees of formulas in two-valued predicate logic. Introduction to two-valued predicate logic. Two-valued predicate logic is a classified logical framework that operates with two truth tables, true and false. It forms the foundation of many logical systems and it is widely used in mathematics, computer science, and philosophy. Understanding its principles is crucial for exploring more complex logical systems, including vector truth tables, propositional and predicate logic. Propositional logic, the student the study of statements and their connectivity structure. Predicate logic, the study of individuals and their properties, study syntax and semantics for both. Propositional logic, more abstract and hence less detailed than predicate logic. Overview of vector truth tables. Vector truth decrees extend the traditional binary framework by allowing multiple truth values to be represented as vectors. This approach enables a more nuanced understanding of truth in logical formulas, accommodating uncertainty and gradation. Vector truth degrees are particularly useful in fields like fuzzy logic and multi-valued logic systems, complex, subjective, normative, objective. Importance of truth degrees. Truth degrees help capture the complexity of real-world reasoning processes that cannot be strictly classified as true or false. They allow for the representation of partial truths, which is essential in many applications such as AI and decision making. The study of truth degrees in pivotal in advancing our understanding of logical systems beyond classical limitations. Complexity levels, low level, the simple problem, well known and standard procedures and practices, no special resources or procedures, medium, complicated problem, manageable with standard procedures and practices, need of analysis and coordination, high, complicated problem, needs the ordinary capability capacities of the organization, projects extra resources, experts, extreme, complex problem, exceeds capacities of the high organization degree of uncertainty, projects, extra resources, experts innovation. Basic concepts of true valued logic. True valued logic is basically based on proportional variables that are either be true 1 or false 0. Logical operations such as and or and not function within this binary framework, producing predictable outcomes. The simplicity of true valued logic makes it an effective starting point for understanding more complex and logical systems. Defining vector truth degrees. Vector truth degrees represent truth values as points in multi-dimensional space, allowing for further flexibility in Interpretation. Each dimension of the vector can correspond to different criteria or context, enriching the analysis of logical formulas. This representation helps model situations where truth is not absolute and can vary based on circumstances. Mathematical representation. The mathematical representation of vector truth degrees typically involves using n-dimensional vectors to characterize truth values. Each component of the vector can indicate the degree of truth concerning various predicates in formula. This this formalism allows for precise calculations and comparisons between different logical statements. Properties of vector truth degrees. Vector truth degrees maintain properties such as continuity and density, which are vital for logical reasoning. They also exhibit non-linearity, meaning that combinations of truth degrees can yield unexpected results. Understanding these properties is essential for applying vector truth tables degrees effectively in logical analysis. Properties of vectors. A plus B is equals to B plus A. A plus of B plus C is equals to A plus B of plus C. A plus 0 is equals to A. A plus minus A is equals to 0. C of A plus B is equals to CA plus CB. C plus D of A is equals to CA plus DA. CD of A is equals to C of DA. 1 into A is equals to A. Applications in fuzzy logic. Vector truth degrees are foundational in fuzzy logic, where truth values can take any real number within a specified range. This flexibility allows for a more realistic representation of knowledge and uncertainty in various domains. Applications include control systems, decision-making models, and natural language processing. Fuzzy logic system advantages, disadvantages, architecture, algorithm, application, membership function. Comparison with classical logic. Unlike classical logic, where propositions are strictly true or false, vector truth degrees allow for a spectrum of truth values. This comparison highlights the limitations of binary logic in handling complex scenarios involving ambiguity. The transition from classical to vector truth degrees represents a significant evolution in the yield of logic. Propositions. There are only two propositions, true and false. Classical logic sees no difference between true or two false propositions. So we have 2 plus 2 is equals to 4. Snow is white is equals to 2. 2 plus 2 is equals to 4. Snow is black is equals to false. If you find this strange or confusing, remember that from the point of view of set theory, we similarly have x from x greater than or x plus 1 is equals to x by x is an elephant that can fly. That is none. Challenges in vector truth tables degrees. The introduction of vector truth degrees brings challenges such as determining appropriate dimensions and interpreting results. Theoretical implications. Exploration of vector truth degrees impacts fundamental theories in logic, including consistency, completeness, and degree. These theoretical implications encourage a re-evaluation of established logical principles in light of new findings. Conclusion and summary. The theory of vector truth tables represents a significant advancement in understanding logical formulas in two-valued predicate logic. Continued exploration of these theory promises to yield valuable insights into the nature of logic and its application in the real world. Thank you.